I love this plugin, select layers, but layer counter. So if you ever have to sell to leadership, is it worth refactoring or is it not refactoring? This is a great one. So the old components I'm showing you here had 13,000 layers, 17K instances, 880 components in comparison to the brand new tag. Let's select this. Let's run last. 800. So you're going from 13,000 to 800 layers. You're going from 800 to 84 components. So this is a drastic reduction.
But then when leadership looks at this, they think about cost savings. So how does this translate to cost savings? I'm genuinely curious.
If you don't know this, but a fun fact about components is every time you bring a variant into your file, you're actually bringing every other variant with it. So if I bring one tag, I'm actually behind the scenes, I'm loading 800 tags just to show one tag. So it causes a drastic reduction in memory. Your files become much lighter. So if you ever run into the instance where you're capping on memory, I think you have 2 gigabytes of memory. At 50%, your file is extremely slow. At 60%, you get the little warning. At 70%, you're good luck saving any work that you do. So you're talking about loss of work, slow to load files. It's just difficult to work with. So the way we're selling this is we're making a system lean. We're making it so that people can work with, not go through the instance of like potentially corrupting a file.
Folks, welcome to Deep Dive, where we take a look inside the Figma files of top designers. Today with me, I have Ian, who is the design systems lead at Uber. So in this interview, we're going to take a deep dive into all things design systems. Ian, super stoked to have you on, my friend.
Thank you, Jay. Glad to be here.
I use Uber almost like every week or every other week when I'm going to the airport, when I'm going anywhere. And it's so awesome to talk to someone who's behind the scenes designing it. And what I want to know is, can you just give me an idea, how big is the design system at Uber? Like how many components roughly, how many variations you got?
I think, so thanks for the question. So I think roughly as of today, just to give some context, I joined Uber just about a year ago. So taking over a lot of the work that existed prior to my time here. Recently with Annotations, we have up to 71 components. So it's pretty large. And out of the 71 components, I think 20 of them is what we consider true core components. So it's an extended set that we have now. And so if you go to our sites, this is what you see today.
But now 71 components, but if you consider all their variations, all the permutation combinations you've got, maybe probably in the thousands, right?
Yeah, it can get a little hairy to maintain at this point. It's good and bad. We're in this effort, we're in this phase where we're essentially rebuilding a lot of our components with a lot of changes that happen in Figma. And so we're in this process of reduction. We're looking at the 71 components with amazing things that you can do now with the variables, especially. There's this whole concept of component-specific variables that allows us to do some really amazing things. For instance, I had a tag component with 89 variants, and it's down only to 20 variants, and it can do.
Can you show me?
Yeah, I'd love to give you a little deep dive on that. And
like that feature, I want to see how you're using that specific.
Yeah, let's do it. So I'm going to show you our base UI kit, our internal UI kit. Again, this is available on our site today. So if you look at our tag documentation, this is a tag component that we use. To give you a point of reference, this is our tag component today. It's variants, as you can see with our latest refactor, but previously, we still have it somewhere. Back then, this was our old tag component. I apologize. Has 880 components. So it's been a pretty massive reduction in terms of component sizing. And this is all done through variables. There's so many things you can do with variables today. So this particular component, if I were to, for instance, change a color to it, we're no longer changing colors through the variants, but we have this concept of a component-specific variable. So changing colors is done through modes appearance. So we're baking in the option at the component level. So I don't have to create tag blue, tag red, tag yellow. I create one tag that has a component-specific control token that only exists in design. From an engineering perspective, this is pointing to the primitives directly. So this is only created for designers to reduce the size of our libraries. So As you can see, we drastically reduced the number of components that we had, and we can do the same things that we could do before, but a lot more now.
Wow. I'm gonna ask you a lot of noob questions because I'm not a design systems expert. So I like that instead of creating variants, you're just creating component level specific, like, variations. Now you showed an example of like how you're changing the colors, like with the tag. What else can you do with this feature? Or just color or something else too?
No, but there's a lot more you can do. So we also have to be mindful of how you apply this and where you apply this. Because certainly you don't want to have too many of these component specific, I call them logic layers. And I'll give you an example of what this looks like. So within my UI kits, I have my variable sets. I have a collection for tag color. Tag is the only one I've created so far, but we're in this process of essentially redoing all of our components from scratch because we can do this now. If you're looking at my tag color collection, I'm pointing to existing tokens that exist today. So we had, I think, over 98 different colors. So if I'm choosing for a gray tag, I have the pseudo design token that's called tag background disabled, tag content border selected. This is all pointing to an existing token in the system today. So think of this as a middle layer between what existing code, and it only exists in design. And so these tokens are hidden from anyone that consumes my library today. So if I were to edit these variables, you can see the scope here, it's hidden from publishing. So nobody that's consuming the library except people that have edit access can see these. So besides color, I will show you a little bit later when we talk about another components, how using the same system to do density. And density is a hot topic for us because at Uber we have, when you think of Uber, often you think of maybe two applications. One, you're calling for a ride, you need to go from point A to point B, but the other one is now you're sitting on a couch and you're scrolling through the menu, or you're hungry and you want to order some burritos. And the density story is completely different. Accessibility is completely different. One, you're out in the street under the sun, and you need a high contrast at a glance. I want to see what that says. There's a very different density need, also accessibility need for it. The other, you're on a couch, you can show a lot more things in the screen real estate that you have. So it's a lot more dense, more compact. So I'm addressing the density, our component density, our product density through variables today. There's so much to share with that.
Oh my God.
So let me show you a list. So a list item it makes up about 80% of all of Uber's applications. So nearly everything that you see is some form of list in all of our applications. And so list is very heavy. It's our most complex system component that we have today. And so the way I'm addressing density per product in list is through variables. So let me just give you a quick example of the final product that you see. Again, this is not realistic examples just for the sake of this. Maybe just grab two of these here. So from a designer standpoint, it's a simple toggle switch where I change the control of list item. So in this case, you can see my mouse pointer here. It wouldn't say list item, it would say just density. And if I change my density from default to compact, let me just select these two so you can see from default to compact. Now my list is a little bit tighter. Let's do it from compact to spacious. So you can see the density is changing. So by default, this address one product need compact, address another product need, all remaining accessible. So we have hard requirements for accessibility. So touch target is a big one. Most of our applications if not, most of our public products are mobile. And so we have to follow the standards that we have for mobile. So even when I go into compact, you see that I still have that 48 by 48 tab target. And then you have spacious. So say if you're driving for Uber, you're using the Earner app, you notice that things are a lot more spacious. You're driving maybe 50 miles an hour down the street. You need to be able to see a lot of information and make sense of that really quickly. So you can't have too much of a dense data heavy information in front of you. So that's how I'm handling. So let's go into the variables here so you can see how that's done. And again, the naming convention that you see here is very different than what I have live. And so in this case, what I'm changing is I have a parent container value that's set, that's controlling the parent container. Then I have a child vertical padding that's changing. And also I'm changing my minimum height depending on the variation that I'm in. So it's every time that I change from default to say compact, the vertical padding is changing for these particular containers within my list, but others are remaining the same. So I'm creating control specific tokens that only exist for designers to use so they can select between different densities.
Real quick. So I think what I got from this whole thing was rather than you creating variants of a component and then having like so many different ones, you're doing it at each component level individually, whether it's for density, whether it's for color, and which is why the amount of different components you have, the variance of it is significantly reduced.
Yeah. Yeah. So it's a drastic reduction in variance that you use. Helps with maintenance because you're no longer having to maintain 800 little tags. You're now having to maintain only a handful. And so it's just a win-win for everybody. Memory optimization, maintenance.
By you reducing the amount of variance, it's led to less memory consumption.
Yeah, absolutely. So right now, I'll give you an example of tags. So if I go back to this is a recent refactor. Again, variable's been out for over 2 years, so this concept is not new. This is our previous tag component. So before variables, we had to create a variant per color, per size. And so that multiplies and grows really fast. So this is something that's been deprecated now. So this is our old tag. And without question, the memory optimization, we were tracking what it was and what it is now. And in this case, plugin that I love to use, I'll give you an example of this, is, let's see, my development. I love this plugin, select layers, but layer counter. So if you ever have to sell to leadership, is it worth refactoring or is it not worth refactoring? This is a great one. So the old components I'm showing you here had 13,000 layers. I had 17K instances, 880 components in comparison to the brand new tag. Let's select this. Let's run last 800. So you're going from 13,000 to 800 layers. You're going from 800 to 84 components. So this is a drastic reduction. And so if you apply this concept for majority of our components, not every component will benefit from component specific logic layer like I do, but some will. Tag in this particular case. Yeah.
But then when leadership looks at this, like, oh, it went from, I don't know, 10,000 to 800 layers now, they think about cost saving. So how does this translate to cost saving the reduced layer? Is it like the application of Uber loading faster? Is it like less calls to the API? Like in layman terms, like how is that tying into cost savings? I'm genuinely curious.
When I publish this library, it might be consumed by a product team. That particular product team might have multiple sub libraries that depends on this component. If my original component is light in weight, if you don't know this, but a fun fact about components is every time you bring a variant into your file, you're actually bringing every other variant with it. So if I bring one tag, I'm actually behind the scenes, I'm loading 800 tags just to show one tag. So it causes a drastic reduction in memory. Your files become much lighter. So if you ever run into the instance where you're capping on memory, I think you have 2 gigabytes of memory. At 50%, your file is extremely slow. At 60%, you get the little warning. At 70%, you're good luck saving any work that you do. So you're talking about loss of work, slow to load files. It's just difficult to work with. So the way we're selling this is we're making a system lean. We're making it so that people can work with, not go through the instance of like potentially corrupting a file, because we really have to think of how this will be reused over and over and over again down the stream. So I'm thinking of the feature designer that's going to be consuming this particular component.
Wow.
Yeah. So this is our old tag. We're going through a soft deprecation method. If you ever had to deprecate something that's used live today, obviously you don't, at least this is my opinion, you don't just change a component and break designer's files. You go through a soft deprecation method. So our old tag, we're deleting this from the system And the only one that you can see today, if you're subscribed to the library, is the new tag. As you can see here, in my case, I had a little deprecated tag and I hide it from the library. But this concept is, it allows us to not break people's files. We only expose the new components. So next time you need a tag, when you are subscribed to the kit, you pull the new tag and all you see is the new one. It's lighter and it can do everything that the other one can do and more. And so for every component that we're refactoring, we're thinking about how will this impact designers that are using today.
Can you not just change it and tag everyone in Slack and be like, hey, tomorrow I'm going to make an update. So you have 24 hours or 2 days to make whatever changes you need to make.
I wish that was the case, but that's just simply not possible. So, and here's why we do it. And this is just best practice for if you have a company for more than one single product where you really have the ownership of the feature and the library that you're publishing. Not everybody is on the same time zone. Not everybody has the luxury to be there in updates. Maybe some designers are out of the country in vacation. And you're talking about teams with potentially tens or hundreds of designers with their own files, their own source of truth. So if I were to modify the source to have a different structure, and if they were to accept that update, you're breaking the source of that file. So one good example, so let's just pretend that at Uber, well, we have a product writer. This is, you call for an Uber. This is the writer app. Maybe the home screen uses a tag somewhere. It's just, if I were to just change that, maybe add another, maybe auto layout frame within the components. And if I were to publish that update, if they were to accept that update, it would probably reset their component back to the default node. What if they made some customizations? What if they changed the color from the default gray to yellow, and now the component's automatically resetting? And designers have no idea that took place because they might not be there. And so this is very destructive. So anytime that we have to make a structural change to a component, we have to go through the soft deprecation method. And one of the things that we've tried before is just moving a component to a different library, call it like the deprecated component library. But then it just became really heavy to do that. And we don't want to maintain zombie components. We give a time frame. I tend to give up to 3 months. And what the time does is, and I'll walk you through the process. So the first step is you bring in a new component to the file. Second step is you mark the old component as deprecated. So you can add a little tag called deprecated. You can also add descriptions within the components, and then you publish that. So you're not hiding the component at the first time that you publish. You're simply publishing the deprecated tag within this tag component. So every file has this deprecation tag. So that's number one. Number two is this. Now you hide it from the library. So in this case, I'm adding a little dot in front. As soon as you add a little dot, you omit this from the library. So designers will not be able to pull this component into their files. So the new component doesn't have deprecated tag, doesn't have the little hidden feature flag. And so the old component now has a deprecated tag and it is also hidden, but we leave it in the library. So there's enough time for this update to take place. So it updates people's files. And so it still exists temporarily. And then after a certain period of time, we delete. So in this case, I gave March 30th for this one, and I'm extending because we did receive feedback. Hey, we need a little bit more time to update our files. But eventually I'll delete this from the library. And then that's when I gain that performance in memory because I don't have to maintain this anymore. And I'm also not keeping this in a particular file. So for every component that we build at a system level, we have a separate file. I keep it in Figma. I've done a little bit of research surveys, at least our engineers to understand, like, what is the preference? Should it be a website where we host this information, or let's reuse Figma? That's where we designers tend to do most of our works today. And I got a lot of feedback that engineers, some of them are really experts. They know their way around. They can find the exact spacing, the token that they need. In this particular case, I created myself here a workspace, and I host all of my components here. So for every component that I build, I have a cover page that's clearly visible from the outside that tells me the most recent status, if we modified something, if we're review, and if it's complete, the name of the person that's working on this. So it's always active. So if I look at this in a month from now, who was the last person that worked on this? What happened? Did I move a pixel? What changed? So as soon as I open this file, I have a cover page and a change log. So I can clearly see what took place. When did it take place? Who changed? So there's a point of contact. If an engineer opens this, he knows who to talk to about this. So that's one basic requirement.
So it seems like by keeping the specs also in Figma along with the component itself, like you're just keeping one source of truth for the engineers as well.
Yeah, the goal here is to create an evergreen source of truth, like truly a source of truth, at least because we have an idea of what this expression of the design language is. This is where we do most of our work, and we have full control over this. And Figma is great for that. You can do source control as well. And yeah, so, I mean, but I feel like this is a matter of an opinion. Some people like to keep it outside Figma, but how do you maintain that up to date? In this case, I feel comfortable annotating and showing all the properties, and I can really handhold engineers through this process. And I want to show you how I do it. So the first thing, I have a cover page and a change log that shows what's taking place. Then I have a page for explorations, and this is the ugliest part of the spec. So if we're considering a change, this is where things get really ugly really fast. We do an audit. In this case, I'm auditing, for instance, if there was a change to list, auditing different products that I'm considering. So in this case, I was making a change for list considering density. I looked at delivery, writer, looked at earner. I have a links to their files to see where that is. Merchant. So I'm looking at different products and how this would serve different products. So there's one-on-ones, there's meetings that I'm having directly with this product team. Maybe it's a whole team of designers. Like, tell me what you've done. How did you break our components to get to what you want? So I can consider part of this audit. Then I take our internal resources. So this could be anything that we've written about lists in the past. Like, how do we think about lists? So I'm looking at every possible iteration, how people broke this component in the past, so that way I can account. And potentially the goal here is to normalize. How do I normalize it into one that works for everybody? My goal here is to create a component that works for all of our products. And I like to tell myself that it should have 90% coverage, and then 10%, these are things that can be either normalized to behavior or it's truly a custom experience for that product that we don't want to support.
Like there's a lot of pressure because like if you're trying to cover for 90% of use case, you're having meetings with different product teams and designers working on that. I mean, you could technically go for 8 months trying to get the perfect components. So how do you set a timeline like, hey, like by June, I need to push out some version 1 of the updated component?
Yeah. So the thing is that the work never ends. It will never end, because tomorrow there's an exploration to do something new. So that is the reason why we have this. We have a single source where we can make changes to it and spread this across every code base that we have, a single place. So to answer your question directly, you have to be okay with not being okay. You have to be okay knowing that this will change. And you have to set expectations for your engineers that what exists today will change tomorrow. So let's make this as lean as possible in code. And sometimes maybe my exploration links to another file outside, but this is a place that I can do the work. And if engineers wants to see, or maybe a designer that's onboarding to this team can see what I considered at this level. Oh yes, Ian at this state did consider this and he chose not to do this. So design in the open, let the ugliness show, and so people can see what you considered. So it's really important to have an exploration page where you consider the audit. Bare minimum requirements, again, cover page, change log, a place where you do your explorations, and where you host your local components. This is not the component that's used in design. Then once you get to the place where I feel really strong that this component can do everything that I need to be, then I go into spec. This is an interesting one. It is the most complex. Let's see if I can pull some examples here. This is strictly looking at densities. We're considering the height of the different cells. I noticed delivery had a different height. Writer had a different applications. So this is a living document. It's not done. If we find a new use case tomorrow that we notice it's a pattern, it's changing, then this is a place for it. We do another audit, see does it work for other people, and then we add to it. So don't just close the book on this. Once you do this version, it's never going to be done. It's so much so that as of this month, there's some incremental changes that's done to the spec. But you're right. Going back to your point, it is considered in the audit. And that's why we put a lot of emphasis on the audits. We have really good connections with the different product teams, and we're speaking directly to the product owners. So the design system designers within these product spaces, they're the domain experts. And so one example, if I'm looking to update maybe the button, one of the questions I like to pose to these product owners, these design system owners within these product spaces, have you had to use one of our components? Did you have to detach to do something that you couldn't do that before? And if the answer is no, then great. So yeah, we're meeting the expectations. But sometimes I will get a request that, hey, I had to override my section heading to be a little bit larger or to have this one thing that you didn't have. Then I realized, oh, wait, what is the implication of that? That implies that to ship this change to code, you will have to build a custom component. You cannot reuse this our component anymore. So maybe it's time to backlog this request so we can update our component to include this. So at that moment, then we consider an audit and how will this impact other products. So I'll give you the very first one. This is the action list. So first, I'd like to just give a quick overview on what this is. I also like to show an example of how it looks. This is not a requirement, but this is just so I can show the density in action for engineers. They like to see that. But first, I give an overview of the components. Hey, this is an action list. It behaves like a button. You can have multiple tab targets. You can have different tab targets. And I have a generic guideline for this. And this is where I'll talk about usage guidelines later. But I want to consider this at this level. Engineers like to understand how this is used. So this is a high-level overview about those components. So high-level overview, I have two sections for it where I talk about this type of list. I have an anatomy section. Again, it's an overview of what the component can do, how I break down into different structures of the list. I'm not really calling this a spec where I'm identifying the space, and just generally, what is the leading content? What is the middle content, trailing content? So generally, what is a list? I talk about the different styles that we can have. So for instance, full width or an inset, different sizes, in this case, the density that we're doing, interactive states, just a quick overview. And I really like to add links to this for different sections. So, hey, if you want to learn about selected list or selection list, go check it out. Here's a link for that. Then we get into really the engineering docs, which is, I do a take on the configuration API. So how is this component configured? What if I need to just render this simple type of list? Pew, 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 I'm a list with the little icon. How is that done? So I show an example of how I create the API and how the API creates this particular behavior. So here's another example of if I need a list with a trailing button, how that's done. So, and in this case here, what if I have a custom components? Maybe it's like a little counter as a trailing item. So how is that called and brought in? Because I'm developing for multiple platforms, in this case, our mobile, iOS, Android, our web, React, and our other web platforms, I go through a thorough review of this. I'm simply covering like the bare minimum requirements of the spec. So just an overview of the components, configuration API of the components. Then I do the color assignment. How's color assigned? I'm always using the semantic tokens. I'm never using primitives. Obviously, there's no expression in light and dark themes if you're pointing directly to primitives. So in this case, my background is this particular background color token. My text is this, and so on and so forth. And I list every single color for every state. So for instance, rest, hover, pressed, active, or selected states, focus, desktop only, disabled. What do I do for the disabled states? I have a special treatment for how I handle images. I made them transparent. So anything that defines the look and feel is covered here in color. What if it's loading? How does it look? What am I reusing? I'm we're using another component that creates this shimmery behavior. So there's a color assignment. Then this is a part of the spec where it starts to get a little hairy. The structure of a list and how do you break down this really complex components in different bits that engineers can make sense. Think of a Russian doll. I like to start from the outside. It's very different because when you design a component, you start from the core and outer. When I'm speccing for engineers, I start from the outer in. In this case, I start with the most parent container of the list, right? So I first identify the paddings, the vertical and the horizontal paddings. I give exact token name. In this case, I need a token that represents 8. I have a minimum height for these containers in different sizes. Then I talk about the different variations here. For instance, a full width variant. How do I handle the divider behavior? So what do I consider none, not having a divider? What do I consider follow deleting text versus a full width? So I'm clearly specifying that, hey, while it's none, the divider is hidden. So giving a visual example, also writing it down. Inset behavior, same thing. Talking about the corner radii token that's attached that gives you the rounded look and feel. Then you get to the leading, the middle, and the trailing content. What do I mean by that? Then I start to specify this particular container must have a minimum width. It has to have these particular properties. And so I'm highlighting what it is and I'm giving exact values to what they are. Then middle container, what is this? How do we break this down? There's specific padding that's set to this. The middle container hosts the top and the bottom. So this one truly is the most complex that we have because it gets really granular and you have to love this stuff. You have to be a little bit crazy to get to this level of detail. Yeah.
This level of detailed documentation that I'm seeing for design system, many teams don't even have that for their own designers, but you have this insane level of in-depth documentation that's meant for engineers. Like,
yeah,
it's crazy as I'm looking at this, like it just had to remind myself like, hey, this is not the documentation that like a designer on your team is going to consume. It's primarily for the engineers and it's so in-depth.
Yeah, it has to be. So, and no, that's why I want to turn the question to you or anyone that's listening to this. If you're supporting more than one platform, how are you making sure that your designs are pixel perfect on every platform? And especially if your product is it's a mix of several platforms. How do you ensure that that is exactly what you design? And so we need to have this level of detail at a core level. So every other product has this high quality component that's applied on every other platform. And so that's why we spent a lot of time in this planning phase, the auditing phase, to understand their needs, and really the speccing phase. A superpower for designers today is if you know how to spec components, if you know how to maintain that spec, if you know how to communicate the spec to your engineers, you have a superpower. You can build anything at all. And this translates to the world where we were in, the prompt engineering, vibe coding. If you can spec a component to this level, you can build any product because you know how to make it pixel perfect.
So I got a couple of rapid fire follow-up questions.
Yeah.
Do you do this level of detailed spec for every single component?
Yes.
Oh my God. Roughly, how long does it take you to even create such in-depth spec for one component?
So I'll give you an example for this particular, the list item. List, it really is the most complex component that we have. So this is a really good example. I think this effort to create this level of detail, I think started November of last year, and I'm still making minor modifications as of 2 weeks ago, but these are minor things. So this one can take a while. I think the part that takes the longest is really once you have a version 1, it's reviewing with your engineers.
Yeah.
And the question that I posed to them is, if I wasn't here and you were given this tomorrow with 0 design input, can you build this to pixel perfection? If the answer is no, I'm not doing my job.
So it's almost like the list component from start of the idea that, oh, we're going to create a component like this, then audit, then creating the spec, is almost took you like 5 to 6 months But now you're at a spot where if you were to go on vacation for a month, engineering can take over.
Yeah, absolutely. I'm in a spot where I have a source of truth. And if tomorrow I want to add or change anything to it, I have one place and only I have the control to change that. I can see who was the last person who modified or added anything to it. And I can,
Where do you see who's
so
modified what?
here's an example. Myself, I added another page or I introduced new variants. I renamed a particular variant on this particular date. Right now, there's only two people. This is myself and another coworker who's helping me with the accessibility part of this backing. So, but again, this is the worst case scenario where it is the most complex component and it takes a long time. But realistically, for instance, a button, for instance, that took me, I think, 3 weeks to develop and another week to review. So I had a system component that can be reused across an entire company until the end of time that's pixel perfect on every platform.
So Ian, I got a question for you. How does a new component get created at Uber? Is it like Ian gets high on coffee and decides today he's going to create a button? Is it like a designer DMs you like, hey, I need a button for the Uber Riders app. Can you create that for me? What is that process like? How do you decide like, okay, we're going to create a new component?
Yeah. So my brain immediately goes, okay, what is this request? Is this a system component or is it a product specific feature that I need to build? And it's really easy to rule those out. If it is a feature designer, maybe he's not aware of the structure or maybe just onboarded and just doesn't know. And then he asked me this question. I filter this out to 2 questions. Is it a system component? Yes or no. If it's not, then you have to build it within your own library. So contact your design system. But if it is a system component, my other set of questions is, okay, have you considered other product use cases? Did you just decide, like maybe you're asking me for a custom card. And my question to you is, okay, great. So what is this custom card? What is the requirement? Do you know who else is using this card or is this just your thing to use? And if it's shared maybe between a product, maybe 2 products, maybe that's not enough of a reason to consider a core component because I need to consider of every platform because once it becomes core, I maintain this at a core level. Then I have to build documentation engineering and front-facing documentations for a feature designer. So it's really easy to triage that question. And 99% of the times, it ends up being a product-specific feature that somebody's asking. There's differentiation, ownership. Yeah.
But then if like 5 designers from 5 different products at Uber come to you and be like, Ian, we need a custom card component and can you design that for us? And we have to present that or get it done in the next couple of weeks. So then what do you do? Because there's a huge timeline.
Yeah. It's a huge timeline, but there's a beauty to that. If I know 5 different products need that, I know I have 5 different people who are interested in that, and 5 different potential designers that I can jam out on this. So if it truly is a system component, then they'll often have some explorations of what it looks like and some idea of like how it looks in product A, product B, product C. And so I can start from that. It's an opportunity for me to educate about the spec creation. Okay, great. Let's create a spec together and I'll handhold the design. First, I'll review to make sure, did they actually consider the design language or they're using the tokens correctly? Did they consider proper spacing? And often what I end up finding is accessibility issues. Did they consider accessibility for selected states, that's a beauty. But if you're a new designer, I highly recommend be an expert of what makes something accessible for selected. So once I address the accessibility issues, I probably have to tweak that card to be slightly different. So at that point, I'm working with maybe 1 or 2 designers from different teams. We're having a conversation where we're iterating this particular component. So we are at that stage at an exploration phase. Hey, let's make this accessible as a bare minimum requirement. Once it meets that bare minimum requirements, the negotiables and the non-negotiables, no, it has to have this. It cannot change to this. Once I have this version 1, then that's where I go into speccing. Okay, let's build this here, what I'm showing. All the variations from color, structure, content priority, accessibility, voiceover, text resizing. Let's stress test this as much as we can. Then once I have a spec, then I can do an engineer review. Then I go to my platform engineers and say, hey, I have a new component that's going to be considered for the system. I know you didn't plan for this. This is randomizing your work that you've built, but can you review the spec? Reviewing will probably take a week or 2 weeks. To build it, it might take a lot longer. So I'm certainly not putting the burden in. However, if this is a feature designer that says 5 different teams need this by next week, then most likely that feature designer has a feature engineer who's willing to contribute to the creation. So as long as we get this done and approved, we can work on a contribution model where the feature engineers can contribute to the core system because we have an approved spec. So it's a beautiful process because you can pull resources from anywhere. If you truly need this yesterday, great, let's build it. Let's work together. Here's the bare minimum requirements for this. Let's go.
Is there a place called Ian Jail where someone who keeps breaking the components and does not follow the design system? Like, is there something like that? Like, what if I have a genuine reason that Ian, like, my reason is that I want to break this component that you've designed so painstakingly, let's say list. I want to take list and completely do my own custom version of it because I feel like it's going to perform better. Maybe there's some growth metric I'm tracking towards, and I have a strong case for, Ian, my version of the list component is going to perform better than yours.
Yeah. Be okay with not being right. We're all human, so I might have made a list item that's in my head, it's perfect. Engineer said it's perfect. Designer said it's perfect. But this one person came around and changed the whole thinking, and that person might be right. So never just like turn that around. So let's really consider what you're suggesting here. Why do you think this is better? Have you considered use case in different products? Have you considered how this is going to be implemented? And then judge based upon that, right? So you can't just shut people down. That's the beauty of designing in the open like this. The whole process is open for anyone that wants to contribute. So if there is truly a valid case, often I would say 99% of the times there is another solution for it. Maybe it's a custom component that's fed within another component. Yeah, often I find a case that they just didn't know about the system and how we work between product teams and horizontal level, that it can be answered fairly quickly that way. No, this is something very custom for your particular need that will not translate well on different products. So as soon as I tell them about the impact of a system component, they quickly realize that, hey, wait a second, actually, this is not going to work for this other product that has a very different need. And so I would say 80% of the job is really selling the concept of the system, talking to people to understand their needs. Maybe 10 or 20% of your time is thinking about design problems, actually working through them. And this falls into the 80%. Let's talk about, it's an opportunity to educate them on where this lies within the system.
And then if you go back to the list component that you created, this is the same list component that's used for consumer-facing app at Uber and also internal and basically anything at Uber, whether it's internal, external, rider app, driver app, it's going to use the same list component, correct?
Correct. Yeah. And so in this, give you one example. For the default density, our rider app uses the defaults. This is what you see on the default. The compact is really considered for Uber Eats. So maybe you need to show several menu items at once. It's really compact, but the bare minimum requirement is 48 by 48. And then you have the spacious, which is the earner. So this is live today code, and there are different needs is there. So yes, it is. So I considered all of those use cases to create this one component that can do it all. But it really gets complex. I mean, we're strictly talking about the colors, the structure, but then what gets fed into the trailing, the leading, then that's where things get hairy. But for everything that you cannot predict, I don't know what people are going to feed into the trailing or leading content. I make every area composable slot in code, but in design, designers have no idea that that's a composable slot. I enforce the rules through design. So as a designer, I can only see the options. Oh, I can pick an icon. I can pick this. I can pick that. But in code, you have the predefined options, but it is a composable slot. So if there's a really edge case where we need to feed something completely custom, engineers know that that is a custom area. So that's how we make something exist for more than a year or 2 years, because who knows what's going to happen at the end of this year. We want this component to live at very least 2 years. I mean, even 2 years is a long time.
Switching gears, can you show me how you're using Figma annotation?
Okay, so let's pretend I need to annotate the structure of this particular trailing content, which is an icon. You can now, within the little comment, there's a comment tools. So they made it available so you can annotate directly in design mode. So this is what I use. So let's pretend that this is a container that must always have a minimum height and a minimum width. I'll normally just drag the height and the width and say, hey, min width equals 48. Cool. And one thing that I like to do is, because in this case, the bounding box is not shown, I like to override this and add a stroke so it's a little bit visible. But engineers know that this is strictly for illustration. So that's something that I do. And you can certainly annotate and call this out here. But I over communicate, even though it's shown in this particular example that the min width is 48, the min height is also 48. On the bottom here, do call it out. Hey, it's written on top and it's written on the bottom. There's no way that you miss this. And here's the settings for every size. So this is something that I'm doing today. So I'm no longer drawing my little red lines. I mean, I really appreciate this feature. This was only available in dev mode. And I think with the recent updates, they added this so it's shown in design as well.
And then the start of the interview, you had mentioned that you have separate specs or variants of the component, one for engineering that they use and one for your own use. Why?
So let me give you, I can use lists as an example. So in this particular file, I have under my explorations, I have a local component for list. So this is this particular component here. So it's rather small. I use for this particular concept, I use a subcomponent structure. I think Nathan Curtis wrote a little bit about that, but for lists, it happens to work really well. So this is where this component, it's called list item V6. I think at some point I have 5.5 with MCV3. This is your Photoshop V9. So it can get really crazy. So the layers may or may not be perfectly clean. They may or may not reflect what they are. And I might have, in this case, I don't, maybe a layer or two that's not included. This is strictly so that it lives separate from the UI kits, because if we do a minor update, or maybe there is some sort of issue with Figma, it doesn't break the source of truth. The source of truth is an evergreen file, and it doesn't take us any more effort to, once we're done with this level, this version of the component, to bring in the new component. Obviously, if we do a major change, again, you're going through the deprecation process. So we do this because we want truly an evergreen source of truth for our specs that's separate from our UI kits. Or in our UI kits, we might do exactly what we did for tag. We might reduce the number of components by a logic layer. We can do it there, but maybe it's not covered in the spec. Sometimes I just want to annotate every variation as a variant here. So the optimization in the UI kit is intended for designers. This is truly intended for engineers. But often I find that it's 90% of the way finished. It's just a matter of cleaning up some naming convention, how I do the layering. So it gets pretty close to the final product, but it's not the product, and I have them separate. And also helps with versioning. If I'm playing around with this version, I'm testing different variations, it doesn't impact what my designers are using today. So I keep them separate.
Love it. Thank you so much, Ian, for coming on Deep Dive and sharing your wisdom about design systems.
Yeah, a pleasure to be here. Thanks, Jay.
Hey folks, this is Jay. It means the world to me that you watched this video. Let me know in the comments what topics you want me to cover in the future, and I will see you in the next deep dive.